In this video, I'd like to just wrap up a few other assorted topics from the packet that are worth mentioning for later, just helping to understand how we use sine and cosine. But another thing about, we can use our calculator to actually find sine and cosine values. What I want to talk about is, well, what does that really mean when I'm comparing it based on, say, radians or angles? But one thing about the unit circle, with the table with all the values like root 2 over 2, the unit circle that we keep referencing, is that it doesn't have all the points. It just has those specific 16 points. What about other points is a question that you're probably wondering about. And how do we do those? But the easiest way to think about that is we can actually use a calculator to figure those out. Like, say, for example, we know that up here is pi over 2, pi over 4, 0, pi over 3, pi over 6, and so on. But, like, what about more numbers? What about more numbers? Say for example, where is 1? Like, if I wanted to move around exactly 1, where would that be? Like, how far is 1? Because if you recall, pi over 2 is really weird. It's 1.57. 1 is going to be somewhere around here, and let's say we wanted to determine it. My whole point here is that we can actually use a calculator to figure out what is the terminal point. Because if I know my distance, well, what I could do is use cosine of 1 is going to return the x location on the unit circle, always, and the sine of 1 will return the y location. And our calculator is completely capable of evaluating any trigonometric point, not just the ones from the unit circle. So this is something we're not really able to solve without a calculator. There actually is a way using what we call Taylor or power series, Maclaurin series, to do this. But it's something that you would never talk about until Calc 2 for those of you who are going to have to get there. It was another very interesting subject in my personal opinion. But I digress. My point is, if we were to use a calculator, again, in radian mode, the cosine of 1 and the sine of 1, what does this mean? What does this tell us? This tells us the location, the value of the terminal point. So if I'm thinking about, well, where is that? The x location would be at about 0.54, and the y location would be about at 0.84. And if I want to know, well, where is this point? That's one way to figure it out. It's going to be there. Also, since that's 1 radian, because when we're not writing degrees, that's always implying radians, we could also figure out, well, what is that in degrees? What is that location? And that's exactly what this first example on the packet is driving at. So it can go ahead and write that over here. What is the terminal point associated to any t value? My point is, you can use a calculator to find anywhere. And we don't necessarily understand how does the calculator figure this out, but yeah, there are ways. And if you've ever wondered how do calculators work, there's a lot of different mathematical tricks that go into programming calculators, which is another very interesting subject. Well, if you're a programmer. Anyways, I digress. Also, understanding location. Another thing that's helpful is converting radians to degrees can really help us understand this too. So if I know, well, 1 radian is equal to, if I multiply by pi over 180, sorry, I need to multiply by 180 over pi to convert from radians to degrees. It's very easy to mix up which way to multiply by. This will actually give me the degree value of 1 radian. So 1 radian is actually equal to 57.3 degrees. And that helps us to see the correlation here in that. And actually, what I'm kind of writing over another diagram which I have. Let me actually erase a lot of this. Sorry, didn't plan this out very well. This diagram is another helpful way of we're gonna very soon move into triangles. But another thing I wanted you to notice about the unit circle is cosine is always indicative of the x location by definition. Sine gives us the location of the y by definition for a particular t value. But notice that if we're converting from radians into degrees, it also works for angles. And what we can also imagine is converting a point on the unit circle to an associated triangle. And all of this weird stuff that we're doing, or it can seem really weird and strange, pertains not just to circles, but to triangles as well. Hence why it's all part of trigonometry. But notice that x, if I'm thinking about the x coordinate, that's always equal to the cosine of the theta value. So if I'm thinking about a triangle, if I know an angle, and this is assuming it's on the unit circle, so you got to be there's a slight adjustment when you're not in the unit circle. The cosine of the angle always gives you the size of the x location, or the base of the right triangle, whereas the sine will give you the height of the right triangle. That's another relevant in how this all connects back to engineering. How it connects back to engineering, architecture, and the like. But so what I'm saying is all this is quite relevant, and I think it's important to get into this and the why. But going back to the actual example, the summary here is that if I want to know the terminal point anywhere at 1 radian, or again, that's the same as 57.3 degrees, I could use a calculator. I could just take the cosine of that to find the x, and the sine of that to find the y. And there we have the terminal point. And say, for example, I want to know, well, what about at 112 degrees? Well, that's going to be in quadrant 2, because it's a little bit past, here's 90. So using degrees is also something which I recommend because it's a little bit easier to figure out what that means and where that is. But 112 is going to be past 90 by about 22 degrees, not quite to 120, but somewhere right about there. And if I want to know the terminal point, I should also expect x to be negative because it's to the left, and y to be positive. And I could quickly check that. You can even change your calculator to degree mode. And that's another thing I wanted to show you in this video, is if I go into mode, I could change my calculator. If I go down to the third line and hit enter on degree, it will change it to now operate in degree mode. This only works with your trig functions, not other things, which I think is worth mentioning. But now if I try to say do cosine of 112, this will now not mean radians anymore. This will now mean degrees. So I can actually skip the conversion. That's one of my points here, is if I want to evaluate trig functions in degrees, change your calculator to degree mode, and you'll be ready to go. So the terminal point at 112 will be negative 0.37, comma 0.93. And that would give us this location, where is the point? So you can expand your finding points on the unit circle or working with triangles by using your calculator.